Okay, you guys can still hear me, right?
Yeah.
Okay.
Yes, yes.
So today we are going to talk about, first of all, acid properties. So let me see, why is this blank? Some issue with my pen, it seems like. Anyways, so Abhinandan, you had this point previously that what are acid properties, and I want to spend some time in order to discuss acid properties in detail today, and then we can see where we go with this. Okay, so let me first of all write the acronyms here. Okay, this is A stands for, you guys can tell me if you guys know what is C stands for. And let's make this very,
Consistency.
very good. Consistency. What is I stand for?
Isolation.
Very good. Isolation. And D?
Durability.
D stands for durability.
Yeah, durability.
Okay. So of course, we will go in great details of these ones. So let's start with the first one, which is uh, atomicity. So first of all, what are these? What are these properties? So acid properties are basically, these are set of properties which should be maintained in a transactional database, right? So what do we mean by that transactional database? What is transactional database? Is it OLTP or OLAP?
OLTP.
OLTP. Very good. Okay. So the thing is, there are certain properties which we need to be keeping in mind in order to design the transactional database, because this is what governs the property of how data would be maintained within the database, right?
Mm-hmm.
So ACID properties ensures that the transactions within the database is maintained, okay? And the data does not lose its integrity in case of any mishap. So two things. So what does ACID property ensure? It maintains data integrity.
Mm.
Sorry. Data integrity in case of a mishap, right? In case of mishap, right? So
Mm-hmm.
what is happening here? Give me one moment. Part time. Okay, now it's fine. Okay, so what are the mishaps that we are talking about, right? So mishaps is can you tell me what is the type of mishap I'm talking about?
Yeah, mishap means like any disaster in the kind of like hard disk failure or
Yes.
server down, or I mean not server down, actually hard disk failure is the main mishap. Um, Something like that.
HT failure is one mishap, definitely. And then we can talk about say mm, you know, in case of power outage.
Yes, power outage.
Power
Yes.
outage, right? Uh, Power. something wrong today on my notes. Anyway, consider this as power. Anyway, so actually, it is actually doing automatic handwriting recognition. I think that is where it is. Is there a way to stop this? I didn't know. Scan. Not sure. How can I stop this?
Notes, right? Okay.
Not sure if it's going to stop corner gestures. Position, oops, mention notification. Anyways, let's see. Let's not waste time. Okay, so you got to this point, right? So this is power outage, right? We are talking about power outage here. So basically, what we are saying is that in case of a mishap, these properties ensure data integrity. That's what is the whole reason of having this property. So atomicity is what? So let's just talk about one by one, right? So let's just talk about first of all atomicity. Any idea, Partho? You want to take a first stab at it?
Yeah, atomicity means like the data should be atomic. I mean, the unique. It should be unique.
No. So atomicity has only one definition. Remember this.
Oh,
It means all or nothing, right? So this now, if you remember this, you will be able to always extrapolate what does this mean, which means that any transaction that is happening in the WebDB system, it has to be treated as a single indivisible unit, atom, right? Atom is what? Atom means what? Atom is basically single and it is indivisible, right? It cannot be broken further.
Mm.
I think I misspelled this. Anyways, so indivisible. Divisible. Okay.
Yes, okay.
Yeah. So what I'm trying to say is that it cannot be broken down further. Why do we need this? Why do we need this? Right? So in order to understand that why do we need this, we need to understand a real life example, right? So say suppose uh, over here you have one bank account and you have another bank account over here. So say suppose you have your checking bank account and the savings bank account, all right? And perhaps Partho, you are not aware of the term of checking and savings, so these are just two kind of bank account. So might be from this account A, just think that these are two accounts that we are talking about. So from account A, I am trying to transfer basically $1,000 to account B, right?
Mm.
And this is account A, this is account B. Okay, this is my use case. Now there can be two scenarios that can happen, right? What are the two scenarios? Of course, it can either fail or it can pass. Correct? You
Right.
are okay with that? Okay. In case of a pass or a successful transaction, what is expected? It is expected that your $1,000 from your account A is
It's transferred to B.
no, it is deducted and it is added to account B.
Right, right.
Correct. Okay. So basically, in the background, if you look at what is happening, can you tell me in the background what is happening?
Basically, one database is deleting
So
some data.
so basically, there is this is what is happening. So there is
Update,
an update statement which
right?
which is doing a balance of say equal to say percent of where say account ID. So this is table name is ACC, right? So this is the query for your account A. This is the query for your account A, correct?
Mm.
Similarly, for account B, there will be a similar query.
Update account balance
Update,
equals to
update account set, say balance
balance plus 1,000.
X,
Where account
balance plus 1000, where
account ID equals to A.
equals to B.
Okay, but shouldn't it be the same account ID on both
No,
the?
we are again.
A and B are the basically the database names, so that's why we have
No, no, no,
separate
no. These are account
IDs.
names. These are account names. These are account.
Okay,
This was
right.
account A. This was account A, and this was account B.
Oh, account name because one is a
Yeah.
checking account for savings, like separate name. Okay,
Yeah.
okay,
Okay.
okay.
Okay. Partho, you are with me till now? Don't know whether Partho is there or not. So anyways, let's proceed. So you understood this part, right?
I'm good.
Okay. So after the transfer, what would happen? The balance on the target account will go up with 1000, and the balance on the source account will decrease by 1000. Correct?
Right.
This is a happy path scenario,
Hmm.
right? Now let's talk about disaster.
সরি কিছু বলছিলে আমাকে
Yes, I think what we are saying is that did you follow this, what I was trying to say, or you want me to repeat?
no, sorry, I actually I got a call.
Yeah, you want me to
That's
repeat?
it.
I can very quickly.
No, actually, this one I'm okay, which you mentioned actually.
Okay,
Yeah.
okay, fine. Okay. So, so in case of a failure, right, this is what is very important to understand. Say, while this transaction is happening, there is a power failure. Can you tell me what would happen?
The transaction will not go through. Maybe it'll just stay there, or maybe it can happen partially, but it will not come. The first
So if
section
the
might.
system crashes after deducting from the source account and before adding to the checking account and before adding to the source, what I'm trying to say is that so there is a power failure over here, right? There is a power failure over here, right? It is now in between. It is deducted and it does not go in. Right?
Database B will not be updated. Then the second query will not.
But your database A will be deducted.
Right.
So what will happen? You will actually lose money and it
Right.
will stay in hanging state. This is the exact problem what Atomicity solves. And in order to solve this, you need to remember it. There are
All or nothing.
no, this is what you do in SQL. Begin transaction and commit. So if you use these two statements in the front of the update statements, That means these two update statements are now treated as one unit. It is
Oh, okay.
within a single transaction unit. So all or nothing will only happen if these transactions are treated as one singular unit. But since these two transactions or then the two queries were different, it was actually treated as two separate statements. Now, if you include it within a transactional block, which is like begin tran and end tran or begin tran, commit end tran, that is where atomicity kicks in. Then you can make sure that if the power failure happens also, then it is not going to be in the hanging state. It will revert back and it will give the balance back to the source. And it will say that the transaction is rollbacked.
Okay. It'll treat both of them as a single statement,
Single
single.
statement, singular transaction, and it will say that the transaction is rollback. This is
Okay.
very fundamental to understand why atomicity is there. So atomicity concept is clear?
Yes.
Okay.
So basically, what you mentioned, like it will be treated as one transaction having two scenario. So either it will go through all, or it will not go through anything.
Correct. Unless you put that into all or I mean the begin tran and end tran block, right? This one, begin tran and commit, it will not happen. It will always be treated as a separate SQL statement because these two are two different SQLs. Are you getting it?
Sorry, come again.
So if you are not having this statement, begin tran and commit, these two updates are two different statements, correct?
Yeah.
Okay.
Means because of commit, like it will be treated as
No,
I mean,
because of the begin tran. Because you are actually asking the SQL server or the database to consider it within the same transaction. And the way to make that as a singular transaction is through this keyword, begin transaction. Begin transaction and end transaction is the only way to achieve atomicity, is what I'm trying to say, Partho.
okay.
Unless you provide that begin transaction and end transaction word into SQL, your atomicity knowledge would be only in books. It is not going to be in the practical world. If I am going to tell you how you are going to solve this problem in an interview setting, this is the only answer that you will give it.
একবার এটা একবার নিচে ইয়েস ইয়ারে দাঁড়াও এক সেকেন্ড দাঁড়াও ওয়েট করো আমি একটু লিখে নিই
You will get the recording, that's fine.
Yeah, sure. No. So basically, atomicity is being incorporated through begin transaction and commit. These two words.
Begin transaction, see, there are different databases who does it differently. In SQL Server, there is begin transaction, end transaction, begin transaction, end transaction, and because there is auto commit on. There is a property in SQL Server that you can do auto commit on, where you just have to mention begin transaction and end transaction. Whereas in Oracle, you have to do explicit commit, right? So what I'm trying to say is that you have to ask the database to treat these two, query 1 and query 2, as singular unit of transaction. Unless that happens, and this is exactly where the interview questionnaire would tell you, okay, you understand atomicity, how are you going to achieve atomicity in real world? And if somebody asks you, this is the example that you will give, right? There are two accounts, account A and account B. I'm transferring money from account A to account B, which means that there can be two scenarios, either pass or fail. So that means that for account A, the balance will be deducted. For account B, the balance would be added. Then that means there are two different SQL statements that would be done. Unless I put it into a begin transaction and within a transaction block, remember this word, within a transaction block, you can just say that unless I put that into a transaction block, this is not treated as a singular indivisible unit of work. The only way to put that into a singular indivisible unit of work is to put it into a transactional block. And that's what you will achieve atomicity with. Okay, that's how you achieve atomicity. Clear?
Okay. Okay. Yes, understood. Thank you.
Okay. Okay, let's move on. Number two. Number two was what? Consistency. Consistency in general, it is nothing but data validity. So what do we mean by that? It means in a high level, a transaction when insured within a OLTP database, when initiated, it must bring the database from one valid state to another valid state. So there is a database and there is this transaction happening T1. What it means is that after the transaction is completed, these two states has to be valid. This has to be a valid state. And this is also a valid state. What does valid state means? So valid state is governed by some, you can say, predefined rule, right? And the rule can be definitely different for different use cases. So one use case can be you are having a database for, say, shop or your store, right? The use case is that basically with that store or shop, you do not want any quantity to go in negative, right? For example, the product quantity cannot be negative is the use case. Correct? Can you actually tell me if the product quantity can be negative?
No, cannot be.
You are false. Product quantity can be negative actually.
Can
How?
be negative.
Product quantity. This is where your transactional flavor comes in. In case of a return transaction, the product quantity is negative.
Sorry, in case of
Return transaction.
redundant,
Return. You purchase
return
something,
transaction.
you purchase something and you go and return it to the shop, right? So I know this because I worked in Levi Strauss for 9 years. So what happens is that so in case of return transaction, your quantity is negative. Now you get the money back, right? How do you get the money back? You get the amount back. How do you get the amount back? Because your quantity is multiplied with the price of goods sold. That will give you negative the amount of dollar that you spent. And that's what is going to be given back to you as credit, right? Anyways, we are not going into that negative, but in general, say for example, in case of a sale transaction, the product quantity cannot be negative. In case of a product sale, like there can be one rule. Or say let's not go into detail. So in case of a large scale shop, I can also come up with this kind of a rule which states that basically the order total must match with all the line items total, which means that I go and purchase, say, 5 products from Amazon or from any shop, right? So 5 products is like $50 or 50 rupees each, right? So how much would be my transaction total? 250, correct? it how is it calculating to 250? Or say for example 5 products are priced differently. One is priced 10, another is priced 3 products. One is priced 10, another is priced 20, another is priced 30, right? So say 10, 20 and 30. This is say my product 1, and this is say product 2, this is say product 3. So what is my total?
60.
60, right? So you can, as a business partner, you can actually implement a rule that my rule is that P1 plus P2 plus P3 should always match to the total, right? This can be one other rule. So what I'm trying to say is that these, what we were talking about consistency, right? So these are called rules, and these are implemented uh, through some checks, right? So these are called consistency checks. And consistency checks can be implemented in two ways. One way is pre-transaction, another way is post-transaction. So
Okay.
in whenever, so let's just write this, right? Consistency check. There can be, what's this blue line coming? Okay, there can be two ways of consistency check. Not sure what's wrong with this one. Let me give me one minute. I'll try to fix something. Mm. Yeah, I'm not sure why is this coming. So basically what I'm trying to say is that, okay, it's gone. So consistency check can be either pre, looks like that I need to find a new way, new whiteboard for teaching. This is not working in my favor. Let's see. Mm, okay. Switched off here. That is why it is doing what carry is switched on or what. Not sure why is this coming. Okay.
Is it the yellow line or the blue line you
The
have?
yellow line is not allowing me to write after this anyway.
Like
So
a page break kind of thing, right?
yeah, that's what I'm
Never
not
seen that
understanding.
before.
Yeah, I'm not understanding why it is coming like that. Anyways, let's just proceed.
Okay.
So one is pre, another is post, right? So these are
Mhm.
consistency checks. So in this case of consistency check, one is pre-transaction, another is post-transaction. So for
Mhm.
pre-transaction, our consistency check can be that the product quantity is actually uh, 3 in this case, right? For
Mhm.
post transaction, what we can do is that we can multiply the product quantity with its price and check the total amount is coming same or not, right? So we can take the product quantity here, that QTY equals to 3, and this can be and we know the price of each line item, right? So we basically get the price over here and we multiply that with quantity. We get 60. So if this and this matches, then basically we can say that this is consistent. So this is a kind of way to do the consistency check in order to do your data validation, right? So our consistency check means that your state that you are leaving from the source and after the transaction, post and pre, you need to understand what is a valid state. Valid state means it abides by the business rule, right? It will follow the business rule and it will abide it by. If not, it will fail. Is it clear?
Mm.
Any question, Partho?
No, I understood the thing that pre-check and post-check, the quantity should be matched.
I am just giving you an example. See, I do not want to teach you acid property because I mean you guys are already like I mean, you guys have read it multiple times, right? But the benefit of having this discussion is that what is the real life way to implement the acid properties, right? That's what I wanted to actually highlight.
Mhm.
So what I'm trying to say is that by definition, consistency means what? By definition, consistency means that my
Data validity.
no, my state before the transaction and the state after the transaction is valid, right?
Mhm.
All
Okay.
that I wanted to give that example of is that what does this valid mean? Valid means that there is a business rule which is governing the state or of the application, right? And that application can be like it's a shopping cart application, which is basically doing like you have a post validation and you have a pre validation. So in pre validation you get the quantity, in post validation you multiply that with the quantity and you equate it with the total. If it is equating, then you are basically saying that with the transaction, I am actually yes, green green tick tick, then I'm good. The consistency is maintained.
Mhm.
Any question, Abhinandan?
No,
Okay, fine.
so far
Let's
good.
proceed. Okay.
Mhm.
So this is actually a very apt example to understand the definition with a real life example.
Yes. I mean, otherwise, this does not make sense to have this discussion.
Right, right. Because theoretically it might be clear, but bringing it up with a live example, real life example makes it even better, in my opinion.
Yes.
Isolation, concurrent.
So, isolation, when we talk about isolation, we are talking about the use case, again, real life, where it is mentioned. So, by what is the definition of isolation? Isolation property definition means that multiple transactions, if executed in one single OLTP database, should not interfere with each other. Correct? Multiple transaction means what? Concurrent transactions. What is concurrent transaction? It means. Can you tell me?
Multiple transactions that happening at the same time,
Correct.
simultaneously.
Correct. What is an example of that?
Um, for example, like in the Google database, let's say multiple users are logging into their Gmail account. It
No,
can
no, no.
happen at the
That is
same,
not
but
right because
that is
your individual account is different. You have to think of a race condition. What is the race condition I'm talking about here? Any example that come to your mind?
Sorry, which condition?
See, isolation, Partho, I think what I'm trying to say is that were you following? I'm just trying to get a real life example of isolation. So isolation by definition means what? Means multiple transaction executing simultaneously should not interfere with each other, right?
Mm.
Multiple transaction means what? Concurrent transactions.
Mhm.
So I'm trying to say in real life, what can be a example that you can tell me the right example of a concurrent transaction execution,
Okay.
which is where Abhinandan just said that multiple users logging in from Gmail app. But that is not the that is not the proper example of isolation because multiple users, when they are logging in, their sessions are different, their accounts are different, right?
Mhm.
So what is a proper thing? So I'm talking about a race condition here. So best example is this.
Okay, okay. Mhm.
Say you have one seat, which is, for example, 12A.
right, 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 right.
So now Partho wants to book that 12A seat, and Abhinandan also wants to book that 12A seat, right? What will happen? Both of you are actually trying to achieve what? Can
To
you tell
book,
me?
Same
to
seat.
book it,
No, that means what? That means what?
to
We are
occupy
trying to
12.
basically
That means exactly what?
we are trying to
To
perform
Let
make
the
me break
same
it down. Let me break it
transaction.
down. Hold on, hold on, hold on. This is very
to,
important. This is very important to understand.
to make the transaction successful.
What transaction?
One is to one is to end condition
No, no,
problem.
no,
I'm
no,
sorry.
no, no, no,
No,
no.
I'm going somewhere else, but update seat status equals to book.
there is a table called seats, right?
Mm.
So what you are doing, basically, you are trying to execute Partho this query, and the same query Abhinandan is also trying to execute.
Mm. Mm.
Correct. Mhm.
Set, everything is dot dot dot,
Mm.
same, where
Customer is Abhinandan instead of
yes, cast
is Ovi.
is OV.
Okay, okay.
This is T1, this is T2. This is exactly an example of isolation. You should remember this. Okay. Now you tell me, at the same time, if you press equivalent time, exact same nanosecond, if you press the button, what will happen? Who will get the seat?
Will it create a deadlock situation?
Yes, that is exactly right. It will run into a lock, right? How do you do a lock for this, right? So you need to understand this is very important. So in order to achieve isolation, each transaction should actually be instructed. Follow my words. Each transaction should be instructed to create an exclusive lock on the database and ensure its atomicity until completed. Did you follow?
Mm.
One more time, please.
So, for isolation, in
Mm.
order to implement isolation, any
Mm.
OLTP database is instructed to
Mm.
have that query execution should have an exclusive lock on the table and make sure that atomicity is followed. So, once you create an exclusive lock on that table, right? Whoever creates the lock first, either this or this, it cannot happen that both the locks goes on the same time, because again, it's just that factor of second that whoever creates that locks first, right? It's also dependent on the nature of the behavior of few airlines who wants to also monetize their product in such a way that they want to sell
Mm.
some tickets in some areas and they don't. That's a different way of. I'm not saying that they get into this level of details, but whoever creates the lock first gets the privilege to
Book
execute
the
the
seat.
transaction, right?
Yeah, right. But here is the hypothetical scenario. What if like both? I'm assuming this isolation or the lock creation will be based on a timestamp or something, right?
Mhm.
Maybe nanoseconds. Hypothetically speaking, what if two transactions are exactly happening at the same time?
It
It
depends on
can
the
be.
database what to select at that point. Point blank, I'm telling you, there is no written rule that can tell you. It depends on the database what to select. And database has its own algorithm to select that. And that is where the internal mechanisms of database goes on, right? So
Okay,
it will,
okay,
it will,
okay.
it will, it differentiates even if the transactions are same. It will, it has to be queued. It cannot happen that in a queue, which is only
Mm.
having a queue of consistency of one block at a time, one block can have two transactions. The transaction queue will have only one transaction at one point of time. So that queue management is, you are basically asking that what happens that in that queue, T1 and T2 are coming in together. That cannot happen.
Okay, okay,
So
okay.
how that queue management happens, we are just saying that it is done through some timestamp. It might not be. It might be something else. It might be very much intrinsic to the amount of resource that the database thinks that it would be needed to complete the transaction. It prioritizes the transaction.
Right, right, right.
Yes,
Makes
it
sense.
might prioritize Partho's transaction better because Partho's name is short than Abhinandan.
Makes
You don't
sense.
know that, right?
So
Right,
So there
right.
are
basically it should really depend on database internal. What is
internal
it?
transaction management queue,
Oh, okay.
right? Now, this is where one very important concept comes in, that if isolation is not done, you know what happens? Remember
Deadlock.
this. No. there is another thing called if isolation is not done properly, then basically you run into dirty reads. Dirty reads are what? Dirty reads are nothing but these are data which is uncommitted. You are reading data which is uncommitted, right? So then again, there are a few other things also that comes in here. One is dirty read, another is, I remember, phantom read. So there are new rows appearing during the transaction. Then all of a sudden after the transaction, it goes away. So what happens is that how to ensure this? How to ensure this? One is this, another is use commit.
Okay.
Commit needs to be used. So begin tran, end tran was the first thing. Commit is the second thing, right? Is this clear this far? Any questions?
So basically, begin transaction, end transaction, and commit, both are applicable for atomicity, right?
No, so begin transaction, end transaction is the only thing that is applicable for atomicity. Commit ensures both atomicity and isolation also, right?
Okay.
So
Okay.
what example I was giving here is that in some cases, like in SQL Server, there is a concept called basically you know how to do a database level setting. You can turn on auto commit on. If you're turning on auto commit on, you do not have to explicitly mention commit, right? So in SQL Server, you do not have to mention commit here, but make sure that you understand this conceptually because it will be asked in the interview that how do you ensure isolation is basically making sure that every transaction or update statement ends with a commit, right?
Yes,
Right.
understood. Mhm.
Good. Okay, I think we are spending a lot of time in this. We'll just quickly go into the fourth one, which is durability. Durability is what? Durability is what? Durability is nothing but it is called permanent storage. What does that mean? Once a transaction is committed, its changes must be permanent. And it can also survive any system failure, right? Real world example. I'm not going to give very, lengthy examples here. I think we all do e-commerce order processing, right?
Mm-hmm.
So you purchase anything for Amazon and everything. So your order details are permanently saved, right? Inventory update is permanent. Your payment record processing is permanent. Have you ever noticed? If your app fails in place of a transaction also, basically that durability ensures that it is also updating the inventory. It is also making the order status, and it is also making the payment correct, right? And it is also achieved through commit transaction, Partho, right? So it is also achieved through commits. So basically, in a transactional life cycle, when you look at, you have a transaction begin, you have a transaction end, and you have a commit transaction, right? That's what it boils down to. I think
Begin transaction. Oh yeah,
I think
right. Makes sense.
I think there are few ways to implement durability. There is something called WAL, WAL. This is called write ahead log or logging. This is something I think these are advanced concept. How do you maintain that or not? So I mean, you generally can think that write ahead logging is basically it's a protocol or it's a method that provides basically atomicity and durability to that system. So there is a principle for write ahead log. What write ahead log says is that there is a log record rule and there is a log force rule. So core principle says that any change must be written to the write ahead log before being written to database pages. There is a logging, there is a logger, there is a transaction that comes in, and then there is a database, right? First thing it says that the transactions, any change, or if this is a change, any change first be written to a log and then it should go into a data page. And all records must be written to a stable storage before the transaction is commit. So this line. So I think there are details around it, but I don't think so that we would require that. But just remember this thing that we need this or write ahead log or anything else. How do we implement that? We basically do a commit, right? We do end transaction, begin transaction, end transaction, and we do commits, right? So the key principle is simple, but it is very powerful. What the key principle says is that before any change is made to the database actual file, which is what is the database actual file? This is database, but there is a file system which it stores, right? Before any change is made to that actual file system of that database, a log entry describing the change should be written. Okay, there should be a log entry to that change that you are making to the file system. What block of data you are changing, how it is changing, and you maintain a log. So that's how you actually, I mean, make that, and this log is supposed to be in a permanent store. So that is one way of achieving the durability aspect of it. I think we are pressed on time. I will end the recording here and then we'll talk. Okay.